Okay, so it's 5:05 UTC already, so I guess we're going to like commence. Welcome once again to session 2 for the first week of the bootcamp. Yesterday we went through, the tutor gave like a breakdown of what blockchain is all about, comparing it with Google, with Web2, right? She also gave like an introduction and explanation to what zero knowledge is all about, right? In today's class, she's going to be deep diving into Starknet and setting up your development environment. So I want to believe you have your system with you, because you're going to be installing some applications and tools that you will need to start developing, right? So she would be explaining what account abstraction is, Starknet architecture, because it's very important that you understand the underlying tech, right? What makes up the Starknet architecture and all of that, right? Understanding nodes, sequencer, provers, and all of that. Why Cairo? She's also going to be doing like an overview of Cairo program structure, how the Cairo program structure looks, right? And then you're going to be having like hands-on setup, installing Agent or Bravos wallet if you do not have it installed already, installing Scab, right? Accessing Starknet testnet via faucet, that's test tokens, and then exploring StarkScan, which is the block explorer for checking transactions on Starknet. There are two. We have StarkScan and Voyager, but it's left to her. I don't know if she will be going through both. Yes, so I'm going to be handing over to the tutor. Hi, Cyndie. Hi, GM.
GM.
Hi.
Hi.
So you can start your session now.
Okay, just a sec.
GM Cyndie.
GM. I'm just cleaning up my screens. Okay, let me share my screen right now. Okay, so what am I looking for? Okay, I'll just come to it. Okay, so GM everyone. Welcome to our second session of the Cairo Bootcamp. So today we're going to go through an introduction to the architecture of Starknet. We'll go through a lot of things actually. So I hope we'll have like enough time. So just in case we are unable to because I have so much to show you guys in terms of architecture, we'll go through so many things. So in the event we run out of time, I'll show you guys. I'll make like a demo on how you can like create like an agent wallet, a Bravos wallet. But the whole point of this class is by the time you get to like creating an agent wallet, a Bravos wallet, you'll be able to understand behind the scenes how the design structure of the wallet looks like. That's why we'll go through account abstraction. And also, you by the time we get to learn Cairo next week, that's why today I'll show you some of the design principles of Cairo, why Cairo is built the way it is. So this week, it has been more of principles. Yesterday, we went through the principles of blockchain in itself, so that when you find yourself building a blockchain, at least you understand the concept of the why we design blockchain the way it is. Right? So today we'll go through the principal structure of Starknet. Of course, it will be using analogies. So I have a storyline created, and also we'll go through Cairo in itself. We'll not go through the syntax. We'll just show you design-wise why Cairo is designed the way it is, and why are we using Cairo and not a language like Solidity. Okay, and also then finally we'll go through how the wallets are designed in Starknet. One thing to mention right now is Starknet's wallet has natively implemented account abstraction. But before we get there, that will be like the third main point we'll go through today, right? So with that, I think we can start. Let me first check the chat to see anything. Okay, nice. There's nothing. Okay, so we can start. Okay, as usual, my name is Cyndie, blockchain developer, developer advocate. If this is your first class, please make sure you've gone through the previous class, because some of the analogies I've translated them to here, but I'll still go through them again on a very quick overview so that you can be able to understand. And in case you have any questions, just some house rules. In case you have any questions, please post them on the chat. You can also also at the end of the session, we'll have like an open platform. So in case you have any questions, etc., you can be able to share them. So I'll be stopping by after some time to check through the chats to see I haven't left anyone behind. So in case you feel you're lost, just say, and then I'll make sure I speak as slowly as possible so that I also don't rush through so many of these concepts, right? Because the whole aspect is once you get the foundation in this week, next week, when you also start learning Cairo in itself, behind the scenes, you'll be able to understand what's happening, and it will also help you in terms of the when you see the way Cairo is structured, you'll be able to understand why it's structured the way it is. Okay, cool. Let's start. So we'll go through Starknet architecture, why Cairo, account abstraction, and then we can, when we have time, we can be able to go through the hands-on, like creating a wallet, etc. But my main focus will be on three principles, so that by the time you're leaving this class, you have understood really well why the architecture of Starknet and also the Cairo principles, okay, and account abstraction, okay. All right. So the first section rather, it's the Starknet architecture. So in order for us to go through the Starknet architecture in real time, I want you guys to imagine that you're visiting a restaurant or a bar. Let's just use a bar, right? Tomorrow is Friday. Friday, it's always a day to like visit the bar. So imagine you're now you've dressed up, you look very nice. You take your friends and you're now going to the bar at night, right? So what are the steps that happen from the moment you like get to the bar till when you leave, right? So we'll first go through that storyline, and then afterwards I'll connect it with how a Starknet like transactional life cycle looks like. Okay, so we can start. Okay, so what happens is essentially, like I said, it's Friday. You've decided you and your friends, you hook up, and then you go to your local bar, right? So the first step, the first point of contact, rather, when you get into the bar compound, obviously, most of the time you'll find like there's a bouncer over there, right? And if you were in yesterday's class, you remember very well when we were talking about ZK zero knowledge proofs, we had briefly talked about the bouncer analogy, right? So you get to the bouncer, and then the bouncer will obviously ask you, are you like over 18? Are you over 18? So normally, as yesterday, the bouncers analogy was more of ZK, but here we'll talk about Starknet, right? So we'll just go through with the normal procedures. So you get there, the bouncer is like, okay, so are you over 18? Show me your ID. And then you show the bouncer your ID. And then if you're over 18, you do what? You get into the bar, right? But if you don't have any form of identification or you look very young, the bouncer will kick you out, right? So remember, the first point of contact is the bouncer, right? So just you can internalize that the first point of contact is the bouncer, okay? Now, once you enter the bar, the next point of contact is the waiter, right? So the waiter will come out smiling, look for a seat for you. What do you want to drink? You order your cocktails or whatever, and then you start having fun. And then after you have fun, it now comes to a payment, right? So the second point of contact is who? The waiter. So the waiter processes everything for you, like, okay, so you want drinks, they bring drinks for you. And then afterwards, when you want to pay up for everything, obviously the waiter who served you is the one who always comes with your receipt, right? And then you pay up. And then once you pay up on their end, I'll give you a scenario with how we bars work here in Kenya. Okay, so we use mobile money a lot. If you don't know, like it's called M-Pesa, right? It's mobile money. So we pay using our phone numbers, right? So normally what happens in a scenario here in the bars in Kenya is that when I pay, obviously I'll pay using my phone, right? I'll pay using M-Pesa. So what they do is normally they go to their end and they check that the money which you've sent, it's been received on their end, right? And once it's received, the waiter will come now with your receipt, with like the receipt that contains that shows that you've paid. Okay, so that's normally what happens here. So you send, and then they check on their end that it's true you've sent the money, or they can even ask you for like the for the transactional code, etc. And then your receipt comes back, right? So that's the third point of contact. We have our bouncer, we have the waiter, and on the other hand, we have the cashier whose work is to confirm that payments are coming in, everything is processed, everything is running smoothly. And sometimes it's the cashier who will process the receipt, which the waiter will bring here, right? And then now, finally, we have the top level management, the guys, let's say the guys who own the bar, or the guys who own the guys who own the bar, right? So normally they'll chip in after a while to come and see, okay, what was the sales of this day? And then the cashier will obviously have balanced the books. They will go through it and they'll be like, okay, so today we've sold this, we've done this, and the books are all checking out, etc. So that's their work, right? So normally the point you won't find like a manager, you as a guest, you won't have the point of contact with the manager, right? But the manager oversees the general operations during which happened at the bar during that night, right? So that's the whole system of how when you go to the bar, obviously things are different, but that's like the general concept of how things happen when you like go to a bar. Okay, so let's now that connect that let's connect that the user flow of how we've entered into the bar to the Starknet architecture. Okay, so the first point of contact, like I said, it's the bouncer, right? And remember, what sort of check was the bouncer looking at? Are you over 18? If you're over 18, you enter into the club, right? If you're under 18, you're kicked out. You don't even enter in, you kicked out, you go home, okay? So how does that translate to Starknet? In Starknet, when you send a transaction, right, as a user, let's say I've said send 5 tokens to John, right? The first point of contact for that transaction, it enters the mempool. This is now where we call the mempool. Okay, it's like a waiting area. Let's call it a waiting area. Okay, so all the people who are sending in transactions, the first point of where they stay first of all is the mempool before they are even processed. Okay, so the mempool is our bouncer, right? And remember, the bouncer, we said there's a sort of check he does, right? To confirm, are you over 18? Are you under 18? So what is the work of this mempool? Okay. The work of this mempool, there's some sort of it's some sort of checks it does before the transactions even enter officially into the processing stage of Starknet, right? Example, have you, let's say you've signed, you've sent like some message, have you signed with the wrong signature? Remember when we were talking about you can have a wallet, but if you don't use like the let's say if you produce like a bad signature, if you remember what we were talking about yesterday, the transaction is like invalid, right? So those are some of the checks that mempool does. Is it have you submitted a transaction with the wrong signature? Is it like an invalid nonce? Is it like a, let's say like the nonce? Remember when we were talking about the transactional based nonce? Every transaction you send, it has its own number. So if I send transaction, it has like nonce 0. If I send another transaction, it has like nonce 1, right? So those are some of the checks this mempool will look for. So if let's say I've sent some money and I've used like the wrong signature, okay, that transaction will be kicked out. it will not even access the transactional processes of Starknet, okay? It will be kicked out, just like how if you're under 18, you'll be kicked out. So it will not even be recorded anywhere, right? So that's the first point of contact, right? So every transaction, remember, bouncer, mempool, okay? The first point of contact is the mempool, and then it does the checks. And then if the transactions are good to go, if they are over 18, they can enter into the Starknet processing system, the club, right? So now remember, we said once you enter the club, the next process is the waiter. The waiter will come, process what you want, give you drinks, and take your orders, etc., right? So with Starknet, the next point of contact is now the sequencer. The sequencer is like the waiter, okay? Once the mempool has validated, okay, these transactions are good to go, they will enter into the sequencer, right? So the sequencer, its work is to execute these transactions. Just like how you will order a drink, the waiter comes and brings it to you, okay? So the sequencer will execute these transactions. And then remember, when we talked about blockchain, we have to produce blocks, okay? Just like how we said in Bitcoin, we have the miners who are producing the blocks, and then in Ethereum, we have the validators who are producing the blocks. So in Starknet, it's the sequencer, right, which is producing these blocks. Okay, so it's not like the validators. Validators are for Ethereum, because the sequencer, its work is now to process all the transactions and enter them into a block. So let's say in our mempool we had like 1,000 transactions, and then 20 of them were kicked out, right? So we have like 980 transactions left. So this sequencer will process all these transactions one by one sequentially. Okay, so right now, if I'm correct, the sequencer it processes these transactions one by one. So if there are 980, we'll start with 1, 2, 3 until they get into 980. But when you like follow through with the updates which are coming with in Starknet, later on you can follow through and see what sort of upgrades do they put into the protocol. You'll find that they want the sequencer to process transactions in parallel. Okay, so right now, that's why it's called a sequencer. It processes transactions in sequence. So it's like if you had 980 people, the waiter will first start with the person at the line, and then you have to wait until, if you're number 980, you have to wait until your order is processed. Okay, so that is one of the currently the mode of execution that is happening in Starknet, but in later on, they will introduce the concept of parallelization. So whereby you can be able to process these things at once instead of having to process one after the other. Okay, so we have the sequencer, it will execute these transactions and it will build the blocks. Okay, so once you've paid, remember we said you had your drinks and then you've paid, right? The next point of contact is the cashier. The cashier, their work is just to confirm that you've paid, and then he will print a receipt showing that yes, you've paid, right? So when it translates to Starknet, this is now the work of the prover. Okay, so I'll show you guys a diagram so you can be able to follow through with me also. But once these blocks are made by the sequencer, they are sent to the prover in Starknet. What is the work of the prover? Remember, we said that Starknet is like a ZK proof. It really works with creating a lot of proof. So the whole work of the prover is just to generate like a confirmation that all these transactions were processed correctly. Okay, it's like to attest that all these transactions were processed correctly. So that's why it will generate a proof. So what happens is, all these blocks, all the transactions in the blocks, they will all be coagulated into one single proof. It's not like it's going to like create a proof for each individual transaction, because that will take a long time, right? So it will just bundle up all these blocks and all the transactions. It will confirm that they are okay. And then once they are okay, it generates a proof, just a single proof. It's like to attest that when the cashier goes through all the people who have paid and then just attest that everyone is okay, right? So it will generate a proof of all these transactions just to confirm that they are executed correctly, right? Now we have the manager whose work is just to come and check that everything is okay. It's not like they're doing anything per se, right? The work is to come and to check the books, ensure everything is balanced out, everything is okay, right? So now that is the work of the verifier, and this verifier, as you'll see in the diagram later on, it it is a smart contract, which is in the Ethereum ecosystem. So it's not like in the Starknet chain, it's now in the Ethereum. So the whole work of this verifier is to pick this proof that was generated by the prover in Starknet and to just confirm, okay, are all these transactions which have been processed by Starknet okay? So it will just verify the proof in itself. And if everything is okay, it will put a tick. So all the transactions are added where? They are added to Ethereum. So let me repeat that again. So we have the bouncer, right? We have the mempool, the first point of contact when a transaction enters into the life cycle, right? So if any invalid pointer that is seen, you're kicked out. That transaction is not recorded, okay? All the accepted transactions are sent to the sequencer, right? Our waiter. And the sequencer has to process every person, just like how you have to wait until the waiter comes to you and processes your transaction because the waiter is one. That's the same thing with how the sequencer is currently working, right? So it has to process these transactions one by one. But remember, we've said, just like how in a club you will bring more waiters, that's what the current work is being done in Starknet, where they can be able to bring parallelization, right? Yes, so that they can be able to process in parallel, so that you don't have to wait for just one waiter to to cater for 980 people. We now have several waiters, so the time is like short, okay? Then now we have the cashier whose work is just to confirm, okay, this person has paid, print a receipt, right? So that's where the prover comes in. The prover just confirms, okay, the sequencer has executed all these transactions properly. Let's create a proof of it, right? And then now the manager comes to just check the records to confirm, is everything okay? Has the cashier done everything right? etc. And if everything is okay, they're like, good. Okay, so that's the same with Ethereum. So the verifier, its work is just to confirm, has Starknet processed all these transactions correctly? If it has done, all these transactions are brought to Ethereum, right? So why is this important? Why is this architecture important? The reason why it's important is because, remember, when we were talking about Ethereum yesterday, it's like how when we were talking about when you have this community and they are directly editing to the Google Doc, okay? But let me just, because I don't know how many people were not in the class, let me just not use that analogy so that I don't confuse anyone. So what I just mean is, just like how Ethereum, sometimes with the way it's working, right? It becomes very slow. Okay, so by the time your transaction is being executed, it might take time. And also, if there's a lot of congestion in the network, what happens? The gas fees go high, right? So the work of all these layer twos, because Starknet is a layer two, it's to help Ethereum in processing all these transactions. So the work of Ethereum is just picking up all the processed transactions and adding them to the blockchain, like settling. We call it in blockchain, we call it like settling, right? So to just add all all the transactions which are being processed by layer twos to where? To Ethereum. It's just that with Starknet, the reason why they have a proof is because it makes it faster. Because, example, if we can execute all the transactions, let's say we execute like 1 million transactions on Starknet, right? And we are creating one proof, only one proof to represent all those millions of transactions. And this proof is just to attest that we as Starknet, we have executed all these 1 million transactions correctly, right? So the only work of now Ethereum is to come, pick this one proof. They don't have to re-execute all these 1 million transactions. No, they'll just come, pick this proof, and be like, okay, let's just briefly check it and confirm that, maybe test here and there to see if everything is okay. And if they don't find anything that is not okay, they pick up all these millions of transactions and they add them to the Ethereum layer, right? So let me first pause there, see if have I lost anyone? So if you have any questions regarding this, you can ask. So let me just take a quick pause, like a minute, and confirm that you guys have understood this. Okay. So I can't see anyone in the chat. So I think to be able to know that everyone has understood, so if you have at least gotten this concept of the higher level overview of Starknet, you can just say yes in the chat, so that I also don't, I also ensure that guys are not just floating and they're not saying. Awesome, awesome, guys, awesome. Cool. Okay, cool. Okay, so let me carry on, right? Let me just carry on. Nice, 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 nice. So just to reinforce this again, right? So when you think about Starknet architecture, always just remember the bar. You get to the bar, you have the bouncer, and then if you are under 18, you're kicked out. So if a transaction is submitted to the mempool and one of the mempool checks is not triggered, the transaction will be kicked out. It will not even enter the Starknet life cycle. And then the next point is the waiter, which will process the payments. That is the work of the sequencer. So when you see a sequencer, always remember the waiter. Its work is just to execute all these transactions which have been brought by the mempool and then build the blocks, right? And remember, right now we are saying in this club of ours, the way Starknet is working right now, we have one waiter, we have like 1,000 people. So you have to wait until your turn comes, right? But in the future, they'll introduce more waiters. It's like they are right now looking to introduce more sequencers. So this work, it's not like a bottleneck in the system, right? And then for the prover, it's the work of the cashier. Once you pay, the cashier enters and generates a receipt for you, and then that's the proof that you've paid, right? Because I mean, you can't be given a receipt if you haven't paid, right? So that's the work of the prover. Picks all these blocks containing the transactions which were made by the sequencer and then generates a single proof for all these blocks, right? And then the manager, it's to just verify everything is okay. So the work of Ethereum does not do any computation. It's like, okay, just bring me the proof. Let me just quickly go through it. Everything is okay. Bring all those blocks. I'll settle them in Ethereum layer, right? So for how many transactions the proof will be generated? Is there really a particular number of it? Um, I'll go give you. I don't think there's like a particular number, but to be sure, I'll make sure to like go read more and then come back and see if there's like a number. But I don't really think there's like a cap to where um to where the number of the transactions will be generated a proof of it. It's only the transactions which will be processed. So based on the blocks that the sequencer produces, let's say it will produce like 100,000 blocks, right? But I'll give you a more show number. I don't have like an exact figure in mind, but I'll give you a number. What is in the main pool? Ethereum? Yes, so it's not Ethereum, right? So what do I mean by, oh, sorry guys. So what do I mean by a transaction? Let's say I want to send you, what's your name? What's your name? Chidima, yes. Let's say Chidima, I want to send you 5 tokens, right? Let's say I want to send you 5 ETH or 5 stack tokens, right? So the mempool, it's like the first point of contact where this transaction goes. On your end in a wallet, when you send money, you are not going to see these things. Here, it's what happens behind the scenes. For you, when you have your wallet and you input like another person's wallet address and you say send, and then you sign that transaction, right? You'll just see as it's gone, okay? But when you check, like even when you go to like a stack scan or something, you'll start seeing like, and I'll show you what that means when I get to the image. But the mempool, it's not in Ethereum, it's in Starknet. So when I decide to send you Stack tokens and I'm using a wallet of Starknet, let's say Bravos or Argent, right? Behind the scenes, now this is now behind the scenes, what we're talking about. Behind the scenes, this is how the transaction is processed. So that on your end, you'll see the recipient has received the money, but it's not like you're going to interact with the mempool, the sequencer, the prover of the verifier. This is just behind the scenes, what's happening. I don't know if I've answered your question. Yeah. So it's not Ethereum. What does the proof look like? Is it a hashed string of characters? Is it really a hashed string of characters? Uh-huh. Let me get back to you. Let me get back to you on that. Let me remember. Is it the proof? Is it like a hashed string? Let me get back to you on that, right? So, um, let's go back to like the transaction life cycle. This is like what happens now behind the scenes, okay? So like I said, we have the mempool here, right? So this is what we're talking about. When you send in a transaction here, this is the first point of contact, right? It's like the waiting area where to be let in to be processed, okay? So the reason why you're seeing this dotted here, validation failed, the dotted means that the transaction was unable to enter into the sequencer. Remember, if your transaction does not hit the requirements which are needed at the mempool, it fails, right? So it's not added to the sequencer, okay? That's why it's dotted. The line is dotted here. It just shows the mempool was unable to validate your transaction at this stage, so it's kicked out, okay? And then the transactions which are received, these are now sent to the sequencer, which we were talking about, the waiter, right? So the work of the sequencer is to take all these received transactions and process them and create a block. That's why you see here L2 block, right? It just means a Starknet block. Sorry, right? The sequencer will process all the transactions, like we said, and then once they are very processed, it will create a block, a specific blocks for it, right? Now this block here, it's now sent to the prover, okay? And when you see Starknet OS, that's the Starknet operating system. It's like the operating system which is inside of the prover, okay? So one thing here which you can see, which even when you've interacted with like wallets before, you always see like accepted on L2. If it's reverted, you'll see like if it's reverted. And then after like some time, sometimes it takes like 6, 7, 10 hours, you'll see accepted on L1. And I'll talk about that later on, right? But transactions, okay, they have two tags. We have accepted on L2 and we have reverted. So what is happening here? Remember, the sequencer has its own checks, okay? So um 5 tokens, right? So it will still enter the mempool, provided I signed with my wallet specifically, like my private key, the signature is okay. The mempool doesn't know anything else. The mempool, its work is just to check correct, is everything correct, right? So the sequencer will now come here and see, so Cyndie is trying to send 10 tokens to Chidima, but she only has 5, meaning that transaction cannot work, right? So the whole point of it is the transaction will still be recorded, right? But it will be given a label reverted, meaning we cannot, it's like we're saying we are unable to like process this transaction, but in terms, we have to still record that it happened, okay? So, meaning, right? And everyone, okay, nice. We are back. But yeah, so just a quick overview, right? So we decided the community will each host their own nodes. So that's the peer-to-peer system, right? And then we decided for the ledger, which I'm talking about now here, Ethereum, right? So yesterday we compared it to like a very global Google Doc where everyone can be able to like access it and do what? And edit stuff on it, right? But where we were talking about, let me just go through that. Yeah, where we I gently introduced the concept of roll-ups was we all everyone in this community realized that if even if they've set the rules of how everyone is going to edit this Google Doc etc, it's still very slow, right? So they decided let's just use Gmail. So if you have, let's say, an action, let's say you want to add to the Google Doc, that example, I made a contract with my neighbor that I'll wash her clothes and she'll pay me like $20, right? And you want to add it there as a contract, as proof that you guys entered into a contract. So instead of directly adding into the Google Doc, which in Ethereum translates to, instead of Ethereum directly processing transactions, we decide to introduce Gmail, right? So you just add it as an email. So you write an email and you're like, okay, yesterday we decided on this contract. Maybe you attach like the contract that you two guys signed. And then now the work of email is to bring um all these emails that the community members are sending, and then they send it to like the nodes which are being held by the community so that they can be able to process all these things, and then they're bundled up and then they're sent to the Google Doc. Okay, so that's what we were talking about in very higher overview analogy. So the reason why I'm talking about Gmail is because when we get to account abstraction, I'll still come back here and show you guys here, because I've used this same analogy to explain account abstraction to you guys. Okay, but let's go back here. Okay, so where were we? Where were we? Yes, we were here. Okay, let me just see. Is there any questions? Okay. Yeah, but that's what, just in case you came here in today and you are not in yesterday, please, you can also go watch yesterday's tutorial, okay? All right. Why is the need for the mempool when the sequencer still does checks and sorts? So, the whole thing is, if, example, let me use the bar analogy, right? Once you're in the club, the waiter will never come and ask you, oh, are you over 18? Show me your ID or something, because you're inside the bar, right? So the whole point of mempool, it's like just to help out the sequencer. Okay, let's do some checks here, all right? So in the event our transaction does not have this, kick them out. In the event our transaction does not have that, kick them out. So it's like just to smoothen the process so that the sequencer, remember the sequencer right now, it's one, right? So the mempool, its work is like to reduce those checks. So in the point that by the time this transaction is entering into the sequencer, the mempool has already validated that some of the checks which we were looking for, they are at a tick, right? That's why when you're in the club, the waiter will not come and start asking you again, oh, are you over 18? Are you over 18? Because they've trusted that the bouncer at the gate, they've done that work. Okay, so these processes help each other out. So the work of the sequencer is just to confirm, do you have the money that you're saying you have? But the work of the mempool, it's just bring all those transactions to me. Let me do the first point of contact of checks, right? So have you signed this transaction properly? Have you done this? Have you done that? Once everything is okay, the rest of the way is to sequencer. So the sequencer, its work is just to confirm, do you have enough money in your account? Are you trying to send money and you don't have enough money? So you see the way they are operating, the sequencer doesn't have to go back and start looking, okay, did you sign this transaction properly? No. So do you understand? Did I understand that? Thank you. Okay, awesome. I'm seeing someone is like writing on the screen. But anyway, nice. So I've seen another, okay. Yeah, so the mempool can be classified as authentication. The sequencer can be classified as authorization, right? Yeah, we could say so, because the mempool will like authenticate, is everything okay? And the sequencer will authorize this transaction is classified to go into, is accepted on L2. This transaction is reverted. Yeah, we can actually say that, right? So the mempool just authenticate that. Are all these transactions okay? Is everything okay? Awesome. The sequencer will be like, this transaction has to be reverted, or this transaction has to be accepted into L2. So yeah, Hamid, I think we can also say that. So mempool authenticates, sequencer authorizes, right? Okay. So we were where? So something which you've seen here, remember I've talked about a mempool and then sequencer and then prover, which generates the proof, and then the proof is sent to the verifier. Actually, when you go check the verifier, it's a smart contract. It's actually publicly available. When we finish the class, I can share it or something. So the verifier, it's just a smart contract in Ethereum, okay? But its work is just to get this proof. Look at it, is everything okay? etc, and then if everything is okay, it settles the transactions. So what is the work of this Starknet core? So they work hand in hand with the verifier in a way that once Ethereum accepts that all the transactions will be settled in Ethereum, right? The Starknet core, let's call it like the state of Starknet, right? So this state of Starknet, its work will also be updating the state of the blockchain. What do I mean by the state of the blockchain? If we've processed 1 million transactions, before we had, let's say, 2 million transactions, right? We've processed 1 million transactions. They've gone through all the steps. Ethereum has decided, okay, everything is good, right? So the work of the Starknet core is also to update on Starknet's side that right now we have processed 3 million transactions. So the next transaction which is coming in is 3,000,001, right? So this is the work of the Starknet core. So that's why they are interconnected in a way that they just send their work is just to settle the states. So the Starknet will settle this, the Starknet core will settle the state of Starknet, and the verifier will settle the state of Ethereum. But in simpler terms, always remember the verifier will accept all the transactions to be included in the verifier, and then the Starknet core, its work is to update that we have processed 1 million transactions. So the next transaction will be like 1,000,001 transactions. Okay, so that's how the Starknet core works in itself. But the major principles in this transaction lifecycle is mempool, sequencer, prover, verifier. So those are like the main 4 points of contact. And also when this is like a some quick homework or something. When you go check like the Starknet documentation, by the time this proof is coming to verifier, it's proven several times. What do I mean by that? They do something technically we call recursive proofs, but we don't have to go through it right now so that I don't overwhelm you guys. But you'll see that if a proof is generated right now, they sort of like confirm, let's say 5 times. Okay, is this proof the same? Is this proof correct? Is this proof correct? Is this proof correct? Once it's gone through that cycle, just to show you how paranoid, let's say how paranoid Starknet is, right? If this proof, if it's generated here, it's not just directly sent to the verifier. Now, behind the scenes of the prover, you find that they iterate, they iterate, and confirm that, okay, we have this proof. Let's rerun it again. Let's confirm everything is okay. Let's rerun it once more. Let's rerun it once more. And then the final point of recursion where they've decided, okay, we've run this proof 5 times, everything is okay. That's when they send it to the verifier. This shows you how paranoid, let me just use the word paranoid, how very committed Starknet is to confirming that all the transactions that they're processing are good. Nothing has happened along the way, okay? I'm guessing that's why in this diagram you'll see like our prover has like some several, it has like some several 1, 2, 3, 1, 2, 3, 4, right? I think it's just to show how recursive this proof is. So it's confirmed like 4 times, and if everything is okay, it's sent to the verifier, and then everything is updated both on the Starknet side and also on the verifier side. Okay. Yeah, I think we've gotten that. Awesome. So based on what we've seen in the Starknet architecture, one person would ask themselves, okay, so for a developer who's coming in to build on Starknet, why do I have to learn Cairo? Like, why? Why should I learn about Cairo? Okay, so to understand the principles, first of all, I wanted you to understand how a proof is generated, as you've seen how the proof is generated, right? So why Cairo? Cairo, first of all, is it's a language that the Starknet team designed themselves. Okay, so when they were starting, to give you guys a bit of history, they started with Cairo 0, which looked a bit more like Python. Okay, so it was called Cairo 0 then. So it looked a bit more like Python, but now we are, I think, in Cairo 2 or Cairo 3, and it looks more like Rust. Okay, so if you've gone through Rust, you'll find like the syntax and some of the methods that are being called, they look very similar. Like it looks similar, even the way it's being handled, it looks similar, right? But in the beginning, they started with Cairo 0, which had more of a Python syntax, okay? So when they were designing this language, they designed it to suit the whole ethos of Starknet, which is prove everything. Do not just trust, prove everything. So what does that mean by saying prove everything, okay? The way Cairo is designed, of which I'll show you guys some extra notes after this, where I've written down like the way some things we will go through, right? So remember, the whole ethos of Starknet is don't trust, verify, right? Don't trust, prove everything that you've done correctly, okay? So when you start learning about Cairo next week, you'll hear this thing like Cairo produces provable programs, provable programs. So what does that mean? It means any program you write in Cairo, even if it's like Hello World, let's say you've written like a Hello World in Cairo, right? And then you run it, you can generate a proof that a proof that you've executed this Cairo program correctly, right? So that's where the whole concept of provable programs came from. Because Starknet were like, okay, we have this system where we are generating proofs, but when it comes to the programming language, we also want it to adapt to the same ethos, the same principle, okay? So every time you write like a Cairo program, of which you'll start writing it next week, once you run it, and you can be able to like generate a proof that the smart contract, okay, or rather the Cairo program is okay, I've run it well, etc, etc. It's like a proof of computation, okay? That's what we mean by saying Cairo is a provable program, okay? So, one thing you'll see, okay, let's do this so that I don't confuse you guys. Let me just go to that. Where did I put it? Yes. Let me just come here first of all. I wasn't able to like compile it in the slides, so I decided to like run it here. So before we go back to the principles of Cairo, right? Let me just give you guys a higher level overview of how you write a program, and then we'll do it extensively next week. Okay. So the first thing is not really. Not really. I mean, it could be like it could help out if you also learn Rust, but Cairo in itself is a standalone program. And once you understand like the foundation behind how it's designed, and example how it reads the storage, how it writes the storage, because most of the time when you're writing smart contracts, you'll find like there's some certain methods which you'll be using over and over and over again. So it becomes easier. That's why I'm really focused on helping you guys understand the foundational aspect of it, so that by the time you're starting to like write Cairo smart contracts, behind the scenes, you know why Cairo is designed the way it's designed. And when you see like you, let's say reading from memory, okay, reading to storage, you're writing to storage, etc., you'll be able to know, okay, why am I doing this? But really, it's not, it could be a plus, but it's not like definite that you have to learn Rust first before learning Cairo. You can learn it as a standalone, provided you don't just go straight into the, let's say, building smart contracts without having first of all understood the whole principle and the whole architecture behind Starknet. Okay, yes. So all right, let's go back here and then we'll get back to the slides. All right. So example, I've written like a hello. This is like how you write hello world in Cairo. It's the syntax is similar to how you write hello world in Rust. Okay. So we have our main function here, and this is just to print in a new line. Okay, print in a new line, hello world. So when we would run this, essentially to just print hello world, just like how you print hello world in JavaScript, Python, etc. Right? So one thing we have here is this, we call it scab. It's like a package, it's like a manager, package manager. Example, for Rust, if you use Rust, you've seen cargo, like how in the simulation that I was showing you guys, I had cargo, right? So, oh my God, I've forgotten something. Before we continue, how did I forget this? I had a Starknet simulator before we even get to Cairo, okay? I almost forgot to show you guys. I don't know why my screen has some of these lines here, but let's continue. So before we continue back to the concept of Cairo, I had made some Starknet simulator just to show you guys what happens behind the scenes, right? So, example, let me say I want to send tokens to someone, okay? So I'll first of all check the wallet balances. Oh, yeah, it's hard here. Okay, so Alice has 200 tokens, Cyndie has 700 tokens, Mike 90, Mark has 0, Bob has 500 tokens, right? So let me say Alice wants to send Mark what 50 tokens because Mark does not have any token, okay? So I'll come back here and I'll pick number 2, submit a transaction, right? So here we have available senders, Alice, Bob, what's happening? Alice, Bob, Mark, Cyndie, and yes, thank you. Alice, Bob, Mark, Cyndie, and Mike, right? So we pick the sender. We've decided we want Alice to be the sender, right? And then there are 3 types of transactions here. You can see invoke, declare, and deploy, but we can just, this is just, we can read more about it later on, right? So if I want to send tokens behind the scene, the type of transaction that I'm calling is called invoke, right? But don't worry about that right now. So this is now what behind the scenes when you're sending money, that's like the type of transaction that's being called, right? So, who is our receiver? Our receiver is Mark. Okay, so what tokens are we sending him? We said we'll send him like 50 tokens. Okay, so as you can see, our nonce is 0, right? So if we submit another transaction, the nonce will be like 1, and then the other nonce will be 2. It increments in levels, right? It increments as 1, 0, 1, 2, like that, okay? So the transaction fee, 5 tokens, okay? That's like the gas fee that we pay, all right? So we now have, we've submitted a transaction. What's the next step? The next step is to process it, okay? So I'll click number 3. So here's where I was talking about the mempool will validate the transaction which you've shared, and then it will be like, okay, the transaction is okay. It sends it to the sequencer, right? The sequencer will process this transaction. We'll be like, okay, we are reducing 50 tokens from Alice. She's paid like a gas fee of 5 tokens. So that's okay. And then it's executed. That's why you're seeing here the remaining balance for Alice is 145 because we've sent 50 and we've cut off the gas fees, okay? And then now Mark's new balance is 50 tokens, all right? And then the sequencer will tag this as block is successfully created on L2, just like how we said block is like accepted on L2, okay? So we have that. Now we've created a block. The next step, remember we said is to prove the blocks, okay? So we'll just click on number 4. Yeah, so here we are here, right? So we've submitted one block, okay? So the prover, its work, it will be like, okay, verify this proof, to verify the proof, and then it will be like, nice, this block 1, it is verified and the proof is generated. So in behind the scenes, so to be like, give me that transaction or that block, let me create a proof of it, okay? And then the proof is generated. Of course, here in the proof, I put like a hash because this is just a simulation. So I just use the hash to like to give you guys like just an idea of how maybe the proof will look like, but it's just like a hash. I use, this is just a system design I used when I was creating the simulator, okay? So we now have a proof. The last stage is to verify the proof, okay? So we come here to verify the proof. Yeah, so the verifier is verifying the proof on Ethereum for block 1, and then the proof is valid, okay? And then we say block 1 is now finalized on Ethereum, okay? So I'll share this simulator so you can play around with it, get to like submit something invalid, you see how it will work, etc. But I just wanted to reinforce and ensure you just as how, in as much as we're talking about a higher level overview, this is how exactly, if we were simulating how the transactions would work in Starknet, this is how it would look like. Okay. Yeah, so I wanted to show you guys that. So back to our Cairo. Okay, there's no chat. But back to our Cairo, right? So we were talking about the design implementation of Cairo. Okay, so we've made our hello.cairo program. We're like, okay, print hello world, right? The next step, of which we'll do this in real time next week, you'll run like scab Cairo run. It's like just to run the program, just like how in Rust you'll use cargo run, okay? It's just a package manager, which we call scab, right? So once you run this, what happens behind the scenes? Have you ever like taken time when you're writing like a program and you're running it and you're getting output? What happens behind the scenes? Okay. So the first step is we have the compiler. The compiler's work is just what's the work of the compiler? The work of the compiler is to take this hello.cairo program and convert it into code that the machine will understand. Okay, because the machine does not understand this. Like, let's say your laptop, it won't be able to understand this. So it has to process it into uh, into a way that machine code, okay, your laptop will be able to understand, right? So that's the first step. So this compiler will take your hello.cairo file, it will run through it, ensure everything is okay, and then now it will compile your code to Sierra. What is Sierra? When we get back to the slides and I show you the principles of how Cairo was designed, we have to ensure safety. Okay, so Sierra, it's like an intermediate representation that runs checks to confirm. Example, have you used memory wrongly? Have you done this? Have you done that? Why did they do this? It's because, remember I said the first version of Cairo was Cairo 0, right? So what happens then? They didn't have like Sierra. When you like run this code, it would jump straight into machine code without any representation. Okay, so when it came down to it, someone would like write something malicious and it would affect the whole system because there's not like a point in time that comes in to check and confirm. Like example, have you used memory correctly? Have you done this? Is your code malicious? etc. So when they now upgraded Cairo to Cairo 1, which is now Sierra, a safe intermediate representation, that's the whole work. Once it gets to Sierra, it's just to confirm everything is okay. There's like no, you haven't used memory wrong, you haven't done this. So when the Sierra output is generated correctly, that means your code is like okay, all right? And then the Sierra is now converted into the machine code, which is just called Chasm, but we can just call it machine code, okay? Yeah. All right. So that's the first step of the compiler to convert it into machine code. Now we have something we call Cairo virtual machine. Let me just write it here. Just like how we have EVM, Ethereum virtual machine, okay? We have now Cairo virtual machine. And the sequencer, by the way, it contains like the Cairo virtual machine to be able to process all these transactions, okay? So what happens is this virtual machine takes up this machine code that we were talking about, right? It now generates something we call an execution trace. Remember, when we talked about the sequencer, sending the blocks to the prover to create a proof, right? Now, when you go one step deeper to see what exactly happens, the virtual machine inside the sequencer, okay? Just in case I've lost you somewhere, please just say, but I'll repeat again until you understand, okay? So what does this execution trace mean? Let's say we have this function print a hello world, right? Let's assume the execution is, what is the execution? Print hello world. So the work of the virtual machine is now to take this as a step, because this is a step of execution, right? Okay, we're just printing hello world. And then the next step will be maybe break, because we've finished the program, right? So this is execution step 1. This is step 2, right? So this is what we mean by an execution trace. It will run this code again using the machine code, right? Step by step. Okay, so we are just, we have like an opening, we have the main function. The work we're just doing is printing hello world, and then we break. So we have 2 steps here, right? And then now it will create a trace of this, of these steps here. Now this execution trace is what is used to create a proof. Let me just pause there and confirm I haven't lost anyone. Okay. Okay, so this is just, you don't have to understand it now, but I'll share this and then you can go through it again and then you can see what happens, right? But just bear with me. I will explain it until you guys understand, okay? So a trace is just like let's say like a history. Let me just call it like a history, okay? So we had two steps. Step one, we printed hello world, right? Step two, we broke the program. The program ended. So it's like just creating a trace. Every step that is happening in the computation, it's like creating a history. We started with two steps. Step one, we printed hello world. Step two, the program then broke, right? Now this trace here is now, it's what now is now used to create a proof. That's why when we say when we say like Cairo is a provable program, this is what we mean, okay? Based on how Cairo is designed, every program that you write, once you execute, an execution trace is made. And this trace is now what is used to create a proof. Let me see. Yes, you'll get this PDF. Yeah, you'll get this PDF. I'll share it. These are just like my extra notes. Okay. Yeah, so I'll share it. Just a second, let me just take a quick water break. Okay, thanks. All right. Let's go back. Let me repeat this again. Okay. We have our hello.cairo. You can just use VS Code. Okay. We have created like our hello world, just a very simple program, right? So behind the scenes, once you run this program, right, what happens? We have the first stage, the compiler. Okay. It will take your hello world and then convert it into machine code. Okay. Then now we have the Cairo virtual machine. Just like how we have the Ethereum virtual machine, we we have the Cairo virtual machine, okay? Its work, it's now to just like create a history of all the steps which we took when we were computing this program. We started with function main. Okay, we have function main, and then we printed hello world, right? And then we ended the program, okay? So it will just create like a history. We have only two steps. We have printed hello world, and then we broke the program, okay? And then now, afterwards, you can create a proof, okay? But then when we get to our next class, because I'll be the one who will be taking you guys through writing smart contracts in Cairo. One thing I'll show you is the difference between Cairo as a standalone program, because you can use it as a general purpose program, okay? You're not like limited to only using it in building smart contracts, okay? You can also use it to do what? To write standalone programs. Like if you write this like this, it doesn't have to go through Starknet. Just like how you create another program in JavaScript, another program in any other language, you can use Cairo separately, but then also you can use it to write smart contracts in Cairo. Okay, it's not like Solidity, where in Solidity you have to write a smart contract. All right, in Cairo you can use it separately outside of blockchain. Whatever you want to build, provided you want to like create a proof of it, you can just use Cairo, okay, and create a program outside of blockchain using Cairo. Okay, but then yeah, let me not go through all these other things because they'll be very comprehensive. But if let me just quickly mention it, but then we can just, it's just a by the way, okay? So when we say we create a proof, something which you have to understand, which will go back to the principles of Cairo, is that this execution trace, like the steps, the execution steps we took, right? How is a proof created? What happens is, let me show you guys. We have step one, right? Print hello world. What happens when it comes here? It's now converted into like a mathematical equation. Let's say x plus y. Okay. Step 2, break the program. What happens here? Let's say we say y plus z. Let me just use y plus z. Okay. So you see these representations here as math. When you now go deep, if you want to go deeper and understand how these proofs are generated, then this can help. But just as just like a quick overview, okay? So we have these processes and they will be converted into what we call mathematical equations. So each step, we had step 1, we printed hello world, right? It will be converted to, let's say, x plus y. And then we have step 2, which is break the program, and it will be converted into y plus z. Now, these mathematical equations, x plus y plus z, these are now what I used to create the proof, okay? So, but let's not go through all this. I'll just share this. These are like my normal notes. So I'll just share this PDF that you can go through it on your free time, and then you'll be able to like understand, okay? Yeah, so that I don't... okay. So I was talking about this execution trace, right? So once we have these 2 steps here, let me go back here. We have this execution trace, right? But let me not talk about polynomials and all these other things. No, let me talk about here. We have this execution trace, right? Which is like a history of all the steps we took to compute our program, right? So let me just push it. Okay. And then, right? So we had our step 1, which was print hello world. As you can see, we were here, a print hello world, right? So, where was I? So the first step is we print hello world, right? So to be able to generate a proof, of which let me reinforce again that it's not like we're going deep into how, because that's now cryptography, just giving you guys a quick overview, okay? So the first step, if we are creating like a trace of all the computations that we've done when we were running our Cairo program, right? The hello world. The first step was what? Print hello world. Okay. And then the next step was we've done it, so let's just break the program. Okay. So let me just like that. What happens? So here there's a step. Each step here is converted into mathematical, like a math equation, to be able to generate the proof. Okay, that's what I was talking about. So if I have step 1, print hello world, I'll do what? It will be converted into x plus y, right? And then we have our second step here, which is y plus z. So this is a principle. It's okay if you don't understand it right now, but once you familiarize a lot with how Starknet and how Cairo works, you'll be able to understand that behind the scenes, every smart contract that you're writing, every program that you're writing, all the steps for computation which are needed to be able to create a proof for this. Now, this is now what happens on a bit deeper level. We do what? They're converted into some mathematical equations. Okay, so like step 1 was hello world. We convert it into the appropriate equation, let's say x plus y, okay? Step 2 was break the program, which is converted into like a mathematical equation, y plus z. The whole point of doing this is because this proof, where it's more of cryptography, right? And cryptography is heavily based on math, okay? So now you have computation, and then now you convert it into math. Okay, yes.
Why are now asking for water? Why?
No, everybody's entitled to one bottle water. How much water? Any other one
Okay.
Yeah.
So you have four extra.
So keep your bottle.
We have a lot of noise.
Please unmute.
Yeah. Okay, awesome. Thanks a lot. Yes, so Cairo, you can use it outside of blockchain. It's not specific to Starknet in itself. Like you can just build it you can build like a standalone project. Let's say like example, the Cairo simulator here, right? If I wanted to, I could have built it on using Cairo. It's just that I used Rust. Okay. So you can just build any program you want. Like if it's a to-do app, if it's a what app, whatever program you want to write, you can use Cairo without having to connect it with principles of Starknet. It's a general purpose language. Okay? Yes, that's what I meant. Okay. Back to here again. Just remember, this is just giving you guys how a proof is generated, but we don't have to go through all this in a deeper level. Okay, so what I was saying is, behind the scenes, when you go deep and you read the cryptography behind how a proof is generated, it's more of math. Okay, that's why this is a very important step. You confirm all the steps. Like we said, we print hello world and then we break the program, right? And then now you convert it into mathematical equations. Of course, it's not like me as a user who's converting it. It's now what's happening behind the scenes to create a proof of your program. Okay, so we have x plus y, and then the step 2 to break our program, we have y plus z. And now these mathematical equations are now what is used to create the proof. Okay. If you want to know like the term is air, like air, the air we breathe. But again, I don't want to like use a lot of jargon that I don't lose you guys. Okay, but for those who want to learn more about it, it's called algebraic intermediate representation. So this is now this. When you see this, but remember again, this is just giving you guys like it's just a by the way, okay? So this is like our x plus y and y plus z. All right, this is now what we call algebraic intermediate representation, which is now fed to the prover, which the prover uses it to create a stack proof, okay? But let's not focus here so much. I just wanted you guys to get the overview of what happens, okay? So when you write a Cairo program, when you start writing a Cairo program, you can always come back to this video and watch again and remember the steps I talked about, right? You'll write the hello world program and then you write scab Cairo run. You don't have to see it right now, but you can see it like behind the scenes that example, the compiler will take, it's the first point of contact. It will take your hello.cairo file and then it will run through it. It will check for errors. Have you done this? Have you done that? And then it compiles your code to Sierra, which is a safe intermediate representation. And by the time you can see like a Sierra file in your program, of which you'll see this eventually, right? This might sound abstract right now, but you'll see it eventually and you'll start connecting the dots slowly by slowly, okay? By the time you see like a Sierra file, you'll be able to know, oh, my code is okay. I haven't like misused memory. I haven't done this. I haven't done that. It's okay, right? And then now this Sierra is now what is converted to Chasm, of which we call it a Cairo assembly, but just call it machine code, okay? Which your laptop to understand, okay? And then the next step is this code now is used to create it's fed to the Cairo virtual machine, which will take up the assembly code, run it step by step, and then to build an execution trace, which will now be created, which will now create this mathematical equations, which we are calling this. But it's okay if you don't remember all this. This is just a terminologies, but I wanted you guys to understand the principle behind how things work. So by the time we're getting to next week, when you start writing a Cairo code, at least you can know behind the scenes. Where do we start? When I run scab Cairo run, the first point of contact is the compiler, and then the next step of contact is the Cairo virtual machine, and then we create the execution trace. It's converted into math. It's sent to the prover. It generates a proof. Whew, that's a lot. Let's first take a quick break. Let me see if I've lost anyone. Okay, in case you have any questions, please, let's take a quick recap. Let's take a quick refresher first of all. And yeah, if you're lost, if you're anything, if you find this is too overwhelming, or if you've understood it, I think let me leave the floor open a bit so I can give you guys some few minutes to internalize. Yeah, so you can, if you've understood, if you haven't, please just you can just write it in the chat and I can repeat again. Yeah, so I'm waiting on you guys. All good? Okay. Thank you, Ricardo. Understood? Okay, thank you, Peter. Okay, nice, nice. Okay, I'll run through it once more. But remember, it's not like it's just a by the way that I wanted to talk about. It's not like it's very important right now because we're still in the beginning, okay? So yeah, but I'll go through it once more. Let me see. Yet to understand, but I believe I would catch up. Okay, let's carry on. Okay, understood, but still dancing like popcorn. Okay. All right. So I remember I have another lesson, so I'll still reinforce this. So by the time we start writing, in my week 3, next week we'll be doing like an introduction to Cairo. So we'll go through the Starklinks book, introduction to Cairo in itself. Once you start writing the Cairo code, um, right now it might sound very abstract, okay, and it's okay. I didn't expect like you'll understand everything right now, but once you start learning how to write with Cairo, by the time you're writing like Cairo scab Cairo run, all I just want you guys to understand is what's happening behind the scene. Okay, so you can always come back to reference this right now because it sounds very abstract, but when you start learning Starknet at a deeper level and when you continue like working on Starknet, learning more about it, I promise you it will make sense. The dots will connect. Okay, yeah. So I'm so sorry guys if it sounds abstract right now, but I promise you you connect the dots. Okay, but let me go through it again. Yeah, so before I continue, so first of all, the Cairo Zero, first of all they wanted to, you know, the way Rust it has some qualities which are really good. Example, it enforces memory safety. Like by memory safety, what do I mean? Example, if I wrote like a, let's say what if I wrote, let me see if I can like write pseudocode for it. Where is my, oh, it's here. Let's come down here. So Cairo 0 to Cairo 1. Okay, so when I talk about they got inspired with how Rust looks like and how Rust handles memory and how Rust handles all these other things, right? So let's write some pseudocode. Let me assign X to be what? To be 10, right? Of course, when it comes to now how memory works in a computer architecture, obviously this will be stored, right? So let's just talk about it at a higher level overview. Let's just say X will be stored in memory with its value. And then we change, like we say X, I want X to be equals to Y. What will happen? X will be scrapped off by the no, let me not use those terminologies. X will be, what will happen in memory will be like, okay, we have changed ownership of X of the value 10 from X to Y, right? So this X will be scrapped off. So the next step will be like, okay, remove X X, save Y in memory, right? Now what happens is, let's say you forget that you had assigned the value 10 to X, and then you start saying, let's say example, print X, and already it's been scrapped off memory. So what will happen? This will like be an error, right? Because now you're trying to access something which is not in memory anymore. So when you go read deep about how memory is being handled in mostly computer architectures, etc., you can see these things. But the reason why the Cairo one, it was designed to like get more of how Rust handles memory. Rust is a very strict language, right? So the way that the principles behind how Rust is designed, like the way Rust handles memory, like if you try this in Rust, right, it will give you an error because it will be like ownership changed from X to Y. Okay, so such qualities as was behind like the system design of why they decided to like change from like the Python like syntax to adapt more of Rust syntax. And when you even check like blockchain in general, you'll see like Rust is a very upcoming language, right? So many blockchains are adopting Rust, especially in terms of building infrastructure because of how Rust is designed and how it enforces a lot of rules. Okay, let me see. Okay. Okay. Group run. Nice. But anyway, that's why that's the whole system design between to Cairo 0 to Cairo 1. Okay, but for the last time before we go to account abstraction, Chidima requested we go through the execution trace again. Okay, it's very simple. First step, we wrote hello in Cairo, right? And then we ran it using tab Cairo run. Okay, the first step, the compiler, the Cairo, let's call it the Cairo compiler, right? The first step, it takes up the hello Cairo program, runs it. So to enforce safety, it will check for errors. Let's say which type of errors. Let's say the syntax says you should write print like this, right? Something like that. But then let's say you forget the question mark for the macro, right? So such things, okay? It will just check for errors. Have you done everything correctly, etc. And then now, this is like the first step of errors it will check. And then you obviously, just like how you have to debug if, let's say you're writing like a piece of code and you get errors, right? It's still the same thing. And then the next step is once everything is okay, it converts to the error. Now, once everything is okay at this point, Sierra is converted to machine code. Okay, machine code. This is step 1. And then now we get to step 2. Push 2. What is step 2? We now have the compiler, right? But we now have the virtual machine. Okay, so we have the Cairo virtual machine. Takes up the machine code. Creates the trace, what we're talking about, creates like it goes through, okay, let's first say it goes through the program step by step. By that we mean, okay, first step, print hello world. Second step, break the program. Like that, right? Once it goes through this is now the execution trace. But you don't have to like remember all the specifics. This is something you can just read as you continue. Just it doesn't have to like read it right now. Okay, so the execution trace steps, of which they are print hello world, and then break the program, are converted to math equations. This is where we got x plus y, y plus z. Okay, and then finally the prover picks this equations and does what, and creates a proof. Yeah, so this is just a higher level overview of how a proof is created, right? But to avoid confusion, I think we'll just stop here. Okay, we'll stop here. Actually, I don't know if it's working. Let me see. Okay, actually, there's a hobby project I'm working on to visualize everything that I'm talking about. So when we come here, all these things, when we started with Hello World, and then the Cairo compiler, and then the Cairo virtual machine, and then the prover, this is just a pet hobby of mine. So just to, it's just an educational platform, right? So you can just come here in the playground and then you input some sample Cairo code. Like let's just stick to the hello world, right? So yeah, so but this is just deeper. So this is like the first point of with this program, this is like the playground. It's still work in progress, but the whole aspect is you can be able to see step by step behind the scenes everything that is working. Okay, so this is just like the first step of the compiler, but let me not go through that. But once it's done and it's like really good, you can use it to like okay, thank you. You've understood, right? Nice. Yeah, once it's like done, we can be able to like go through it, and you can see step by step what happens to the point where you can be able to like create a proof. Okay, but that first step is just the compiler step behind the scenes. Okay, but yes, so
Sorry, Cyndie, please. Okay, so I wanted to add this. Akintayo
okay,
created a link to join the a WhatsApp group he created. I don't know, for study. So, but I think it's best for you to maintain the Starknet Africa Telegram channel and colonies. Reason being that there are people that are very good that would answer any questions or any blockers that you might have as you are on this journey,
Okay.
right?
Yes, you are very correct. Actually, I'm just doing this based on my experience. You know, as students, we should have a group on our own, and it's just not for everyone, actually. You
Yes,
understand?
please, you
Not
can
for everyone.
maintain the colonies. The colonies, you can always like have discussions as regards that, please. Yeah. Please, Cyndie, you can continue with the class. Thank you.
okay. So back to based on what we've seen so far, what I just wanted to show you guys is by the time you start familiarizing with Cairo, it's okay because this is the first step. Most people might not have not have like gone through Cairo, right? But I just wanted to show you guys the principles behind how Cairo was designed, the way it was designed. So the more you continue learning Cairo, the more you connect the dots. as you continue, okay? You will remember, oh, okay, we talked about Sierra. Oh, okay, there's a reason why it's like this. Okay, okay. And when you like run the scab, you'll be like, oh, okay, the first step Cyndie said was compiler, then Cairo virtual machine. So when we reinforce little by little, you'll be able to understand, okay? But this okay. So yeah. So why have I gone through all that to show you guys? It's because when you check like the principles of how Cairo was designed, like I said, the whole ethos of Starknet is prove everything. That's why when we started with like the architecture of Starknet, where we said the mempool, the sequencer, the prover, the verifier, at each point in step, the whole aspect is just to create proof that everything has been done correctly. And that's why they designed Cairo, okay? So even Cairo in itself, the way it's designed, when you like write any Cairo program, always remember behind the scenes, it has been designed in a way that a proof can be able to be created for it, okay? What do I mean by deterministic? You remember when I was talking about hashing yesterday on the principles of blockchain, when I said, just like how hashing works. Example, if I put raw materials, like we were talking about a smoothie, right? If I want like a banana smoothie, every time I put one banana, one glass of milk, one pint of sugar, I will always get the same smoothie, right? So that's what we call in technical jargon, deterministic. When you put the same input, you'll always have the same output. I can't wake up one day and put like one and blend, let's say one banana, one a glass of milk, one pint of sugar, and expect, let's say, another smoothie, like a strawberry smoothie or something, right? I will always have the same output. So the principles behind Cairo is when you write a Cairo program, the same execution trace will always be generated. Just like how we've talked about our previous execution trace, where we said, okay, we started with print hello world, and then we closed the program, right? There's at no point in time you'll find a scenario where we'll say, okay, there's like another step inside or something. You will always have the same output, okay? The same execution or trace, right? The same deterministic output. So even when you go read like the Cairo white paper, etc., these are some of the things you can be able to like see in depth, okay? The third thing is, remember, like I said, every step is represented as a math equation because these math equations are what are used to create a proof. When you now go deeper into cryptography and all these other things, right? Arithmetic design. And what do I mean by no hidden behavior? Although, again, I'll reinforce again. We'll go through this again when I come and teach you guys about how we build our first smart contract. I'll show you guys what I mean when I say no hidden behavior. Example, if you've ever written Solidity, right? Let's say you have like let me first see how many people have like written Solidity or something. Yes, the outcome is always objective. Everyone expects the same outcome. Nice, 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 Chidima. Yeah. So I'll show you guys what I mean by no hidden behavior when I come up with like a Cairo Solidity program, and then we will compare it with a Cairo program, how it looks like, right? So let me see. Nice. So you're conversant with Solidity. So normally, but remember, I'll show you guys this again. Okay, so we'll go through this again the next week after, the other week after this. Okay, but just to mention lightly, in Solidity, let's say I want to write like a smart contract that will enable someone to like send tokens. Behind the scenes, you will use like the transfer function, right? But let's just say I've written a function that will help someone send tokens from one person to another, okay? Behind the scenes, what happens is, the way the Ethereum virtual machine is designed, etc., there's some sort of steps behind the scenes that you don't even think of, like memory, etc., all those things you don't handle. Solidity, we say it's like it's like you're writing business logic for blockchain, okay? But now when it comes to Cairo, as you'll see later on, you have to like write so many things manually. okay? Like I was telling you, which you'll see this again, you have to like go back to memory. Let's say read something from memory. If you want to write something to memory, you have to like you have to like directly write about it. So the whole aspect, the whole principle behind this is that to be able to, it's just writing, they are now what will be created into mathematical equations, which will now be created into a proof, okay? And then the Sierra, we said it's an intermediate layer to prevent, example, someone writing malicious contracts, okay? Ooh, that was a lot. That was a lot to take in. Let me see if we are okay. So remember, I'll show you guys real time what I mean when we'll go through when we like write smart contracts, what we mean. You'll see like the differences between Solidity and Cairo, right? It will help to like internalize. Okay, just a quick break. Let me see how a guy is doing. How are you guys holding up? Today we've learned a lot, and we still have one last thing to go through. So how are guys? How is the mood? Okay, so one last thing that I wanted to talk about is account abstraction. At least this one, we will not go deeper as why the principles of Cairo, okay? So you can relax, right? So what is account abstraction? And why does this matter? Because the more you interact with a Starknet, like I was telling you guys, when you go and create like an Agent wallet or like a Bravos wallet, right? Behind the scenes, you'll know, okay, this is account abstraction. But before, let's just go through it as a higher level overview, okay? So let's go back to our analogy for a Gmail, right? So for those who are with me in class yesterday, we talked about using Gmail as where you can be able to like write an email and you send some tokens using Gmail, right? So let's just assume it's like that. So what we talked about yesterday was, example, I opened my Gmail, which we connected it to like a blockchain wallet, right? And then I type in John's email address, which we said it's like the public key, the wallet address, right? And then I type a message, send 5 tokens to John, right? That's similar to like creating a transaction, okay? And then I click send, and then I type in my password, right? This is the same as when I sign the transaction with my private key to be able to ensure the transaction is like successful, okay? And then Gmail sends it to the community servers. Remember, I was giving you guys how yesterday we went through creating like Google as a decentralized service, right? So the community's Google servers, okay? The transaction is broadcasted to the network, which is the network of the servers, the Google servers, okay? The P2P network, okay? The servers, they get this email, they process it, and then they deliver the mail, right? Which is the same as the nodes will validate this, and then they send the transaction, okay? Now Gmail will add this email to John's inbox, okay? The transaction is included in a block, and then John opens his inbox and sees the email. John's it's similar to like John's wallet balance is updated, right? So we had gone through this yesterday just to show you guys how a wallet would feel like if it was like Gmail, okay? So let me see, where is that? Yeah, let me yes. Yeah, so that was what we had gone through this previously, okay? But what is the design challenge of this wallet? Remember when we said once someone accesses your password, they have access to your Gmail account, so they can send emails on your behalf, right? It's the same with the current wallet structures that we have in example in Ethereum, okay? Let's say like MetaMask, okay? Once anyone has access to your private key, essentially your wallet will be drained. And I don't know if you guys have been in the trenches like I am, but at one point in time, our wallets have been drained, right? And Security wise, I mean, imagine you're now going to like tell people to come to blockchain and put money in a wallet, but now you're telling them it's not like a Google account where if I lose my password, I can recover it. Once I've lost my private key, my money is gone, right? Obviously, that's a very big issue because in my mind, I'll be like, why should I put my money somewhere where I'm not even sure? Anytime, any day, someone can come and drain my wallet. Okay. So this is now where account abstraction comes in. Well, this is one of the biggest challenges we have, right? If someone has access to my Gmail password, they can impersonate me and they send an email address to John and they drain everything from me, right? So what do we do? First of all, these wallets, they don't even know who the real owner is, right? It's not like how in, let's say, Gmail example or like a Google account where someone may try to access and Google is like, someone who is not you is trying to access your account and then they give you some details, blah, blah, blah. And then you like reinforce, you like put in a new password, all these things. In blockchain, once someone has your private key, even if they're like in another country or somewhere, they'll just the wallet will just assume this is the owner, so they will just use that they will just drain your wallet, they will remove all your money, they sign that transaction with your private key, and that's how your wallet is drained. Okay, so this is now where a concept we call account abstraction comes in. So now I'll go back to this again. Let me come here, Gmail as a smart wallet. Okay, yes. So what I was talking about, MetaMask, it's called like an externally owned account. Okay, so it is ruled by public key, private key. Not your keys, not your coins. You use your key, you lose your private key, your wallet is drained, right? So let's go through it step by step as to how we can redesign our Gmail wallet to be like a very smart wallet. Okay. So in our previous scenario where you were watching, we were logging in on Gmail using only password, right? So if we want to create like a very smart wallet, okay, I can log in using Face ID. You know, these days, the way you can like log in using Face ID, you can put it like a fingerprint, you can put in etc. Imagine instead of having to use only your password, imagine if we can log into like our Gmail wallet using Face ID, passkey, etc. Right? That would be so nice. Okay. I'm not only confined to my private key. I have other ways that I can log in. Okay. Now, how does this help? Remember when I was showing you guys how we will send money using our Gmail wallet, okay? So I come in, I type John's email address, and then now for that email to go, I sign with my password, right? Just to confirm that it's me, okay? Now, if Gmail was a smart wallet, I can auto sign it with Face ID. I don't have to like manually type my password everywhere. I send to John some tokens. I have to sign with my password. I send to this person. I have to sign with my password. Then I have to manually type it. Okay. I can just use Face ID. So I write what I want to write and then Face ID, it's done. And or if I want to like put two-factor authentication, let's say just to confirm it's really you know the way you put like SMS verification. So if you want, it's the same thing with our smart wallet. Like you can, before signing anything, you can be like, okay, send me an SMS to like my phone number, or send me an email to another email address, which I've used just for security. Okay. So you have that freedom to add these extra points of security. Okay. Now, with our smart wallet here, one thing you notice is we have to send emails one by one, our Gmail wallet. So I have to first send my email to John, process the transaction. I have to now send another one, process another transaction. But if our Gmail wallet was like a smart wallet, what will happen is I can add extra features You know, I can decide to like batch send emails. I can decide to like schedule emails. I mean, I know this in real world they are in Gmail, but imagine if we had Gmail as a MetaMask wallet. Okay, that's what you're doing. So I can batch send the emails. I can schedule like send this email at around, let's say 10 p.m. Okay. One thing which is very important, if my password is lost, my Gmail account is lost, right? Because first of all, how will I able to like send an email and I have to manually sign the password and I don't have it, okay? But if Gmail was an account, a smart wallet, right? I can set up recovery emails. I can set up like a recovery email. I can even use guardians. What guardians means, I can bring like my mom or my sister, and they have them like trustees. When I lose my Gmail account, I can be able to recover using, let's say, their Gmail account. Okay. So even if I lose my password, I can still be able to recover it. Okay. One thing we were also talking about is anyone who has my Gmail wallet password can act as me and send emails on my behalf, right? But now we've included extra points of security. We have Face ID. I can use like a passkey. I can use, let's say, like Google Authenticator or Authy, all these other authentication, like the 2FA methods that we normally know, right? So even if someone has my password for my Gmail wallet and they log in, it's not like they have my face or anything. So even if they try to like send a transaction using my Gmail wallet, they'll still need to include like my Face ID or like an extra passkey. So there's nothing that they can do, right? One more thing. Remember when we were talking about how you need to pay for gas fees so that people who are running the nodes, they can be able to like have money coming in so that they can be able to be incentivized to continue running the nodes, right? So normally with how example MetaMask works, you'll need to pay gas fees with ETH, right? I can only use ETH, right? But if we have like if our MetaMask account is like a smart account, I can use any other token. Okay, I can use USDC, I can use any other token that I want to pay gas fees. So I'm not only confined to ETH. And this is something because I don't know if you guys have ever been in a situation where you want to send money to someone, but you now have to start looking for ETH to pay for gas fees, right? But in smart accounts, you use any other token that you want to use. Okay, you can use USDC, you can use all these other things. Now, just like how all of us, we have like the same Gmail setup, okay? It's not like you can over customize it or something. We still have the same Gmail setup, etc., right? We're using like a one size fits all user experience in some of our Gmail accounts or our Google accounts, right? But now, if it was a smart account, you can customize Gmail to whatever you want. So if you have like an extra feature or you have like an extra request, maybe you want your emails to look like certain way, maybe you want to like I don't know, maybe you want to like just whatever your imagination comes in your mind, you can customize it to what you want personally. Okay. And one more thing, which is very important, I have to pay my gas fees personally. Okay. But if my wallet was a smart wallet, I can even have someone from, let's say, the company where I work at or a sponsor. They can come in and they can pay gas fees on my behalf. So my work is just to transact. There's someone now we call a paymaster whose work is to pay for gas fees for you. Okay. So this is now Gmail as a wallet, but let's now go back to like a MetaMask, okay? So with this in mind, let's now start talking about MetaMask versus wallets in Starknet, okay? So the first step is, if I want to sign something using MetaMask, obviously I'll have to use my private key, right? And that private key, you have to guard it a lot because if anyone can be able to access your private key, they have access to your account, right? But when you come and check like how you can, example, if you like creating like an agent wallet or a Bravos wallet, you can use like email sign up and you can set up things like, use a Face ID, you can use like a passkey, all these other extra features which our MetaMask wallet does not have, okay? So also the same thing, if I want to send money I have to sign with my private key all the time if you've used MetaMask, right? I have to keep on signing, sign. But if you use like a Bravos wallet or an Agent wallet, you can send a transaction, especially if it's in your phone, right? You can just scan your face with Face ID and it's like, oh, tick, we've verified it's you. You just continue sending money. So there's nowhere, most of the time you'll find like there's nowhere you're interacting with the private key at all. Okay. So like I said, if your password, if you like your private key for like your example, if you even lost like your secret face, the seed face, right? That account is lost when it comes to MetaMask. But remember when we were like opening up an account for Agent or for Bravos, we set up like a recovery email. It's just like how you can create like a Google account. It has a very Web2 experience, which you'll get to see, right? So you can recover it using your email address. Or like I said, you can have the concept of guardians where you can have like another trusted party to be able to recover the account for you. Okay. So remember, one issue which is very annoying about MetaMask is that if someone has stolen like my seed phrase or like someone has access to like my private key, they can act as me. So I now have no autonomy over that wallet at all because my money will go and I'll be looking at it while it's leaving my wallet, right? But when it comes to now these accounts, like the Bravos and the Agent accounts, someone can still access your private key or your seed phrase or something, right? But if they don't have the extra steps, like if you put like a pass key, example for people who are using like a MacBooks, we normally have that thing that where you put your fingerprint to scan, right? Or if you're using it in your phone and you put in the setting where you want to use like a fingerprint to be able to sign the transactions, this person will still have access to your account, but it's not like they have their own your fingerprint or your face, right? So they can't really remove money from your account because we have this extra point, which are put like two-factor authentication. Okay. One thing which is also super interesting is when it comes to MetaMask, you have to have ETH token to pay for gas fees. But when it comes to Starknet, you can actually use USDC, you can use USDT, you can use the Stark tokens, you can use the ETH tokens, you can use those kind of tokens to pay for your gas fees. So if you're interacting and it's not like you have ETH in your wallet, you don't have to now start looking for ETH to pay for gas fees, okay? You can be able to pay for it using USDC, USDT, okay? Now, when I talk about everyone in the community has the same Gmail setup, all of us will have the same MetaMask account. Whether it is operations, whether it's the way MetaMask is operating, it's not like you can be able to like add extra features the way you want. But with the way smart wallets like Bravos and Agent are designed, you can actually customize it. And by customizing it, what do I mean? When I talk about like smart wallets, what I just mean it's an account, it's a smart contract. So when you see like Bravos and you see Starknet and when you see like Agent, they're just smart contracts. Okay, so if you decide to come and you create like your own wallet in Starknet, you actually can because you just have to follow the of which I'll share this by tomorrow. I can show you guys like an example of a smart contract for an account contract, right? Provided you put the specific methods which are given, which are standardized by the industry for Starknet, okay? So that your smart contract can be recognized as a wallet, provided you put all those functions and then you add in the extra functions you want. Let's say I want to have like a multi-sig account where before money gets out of my account, several other people are signing, right? Or I want to add another feature like this, or I want to add another feature like that. It's not like MetaMask. MetaMask does not have example like a multi-sig account, right? But if you decide you want to create your own wallet to serve your own purpose, you can actually do so and it will be very recognized, okay? So when I say customize, what I just mean is the developers can add more features or more whatever they want, or you yourself, you can actually come and if you understand the logic behind writing if you understand the logic behind how to write like a smart contract wallet, you can actually write it, you deploy it, and then you start interacting with your wallet. Okay, it's that easy. And then one more thing, in MetaMask, no one can pay you your gas fees for you. And sometimes, you know, the way in MetaMask, the gas fees can be really can be sometimes high, right? But in Starknet, because the agent accounts and the Bravos accounts, they are all smart contract accounts. That's why we say Starknet is natively employing account abstraction. Okay, so we can have like a paymaster. Example, if you've been following through with Starknet, there's an initiative they've had where anyone who's building like a product in Starknet, they'll be able to pay gas fees for your users for you at a certain level, okay? So even when your users are interacting with your product, which you've built on Starknet, they don't have to pay gas fees because we have like a paymaster who will pay gas fees on behalf of every user. Who is interacting with your product in Starknet, okay? So this is just to give you guys, when we talk about account abstraction, this is what we just mean, okay? So you have the autonomy to add extra features. You can add things like social recovery. So the whole point of account abstraction, it's just to give you guys like a Web2 experience, like a Web2 user experience of how things operate in terms of services in Web2, okay? And when we talk about account abstraction, it's like we are abstracting, we are removing the account model, which is for like MetaMask, okay? Like when I was talking about the externally owned accounts, etc. So when we talk about, when you hear people mentioning, oh, account abstraction, because it's something which is also been mentioned in the Ethereum space, like the ERC 4337, but that's just you can read about it in your like in free time. So this is just the principles behind how account abstraction is really good, because when you use these wallets, they increase security. Like at least you're assured that you can't just wake up and, let's say somebody who like you clicked like on the wrong link, example, and they created like a script which was able to like derive your private key, and then boom, all your money is gone. But once you have these features for these wallets like 2FA, etc., it's so easy to be able to secure the wallet. That's now the principles behind like account abstraction. So Starknet wallets, they are just natively smart wallets natively. That's something that you get to see. Okay, so let me see. Nice. So that's what I mean, okay? So yeah, so these are just the principles. You can recover your account. You can decide which token to pay gas fees with, and you can have the paymasters. You can sign a transaction using your Face ID, your passkeys. You can even introduce like multi-sig. And these are just some of the principles of account abstraction, okay? So I'll just go through that some time back because we've gone through a lot, but yeah. Oh, guys, we have gone through so much today. Yeah. Oh, we've gone through a lot, but yeah, so that's more of it in terms of like account abstraction, okay? So yeah. Any questions, any feedback? I know today we've delved into a lot of very deeper concepts, but within time you'll be able to like understand and iterate on them slowly by slowly. Okay. Yeah. So let me get back to the chat. By existing wallet, what do you mean? Like an existing outside wallet, or because Bravos, it's a team it's like a team of wallet developers who built Bravos in itself, okay? So if you decide to use Bravos, you go with like the logic yes. When you like use Bravos, obviously you'll use like the logic and the features as they added, right? But if you decide, okay, so what I'm trying to understand, when you say existing wallet, is it like an existing Bravos wallet or like an external wallet? Yes. Okay. Yeah, I can explain slides 16 and 19. I just wanted to like give a breather first and see where people are at, because today we've like gone through a lot. Yes. So this is now account abstraction. So you turn your wallet into like a programmable smart contract. So it's now a smart contract wallet where you can add in all the logic you want instead of just a basic address. Yes, that's like a also like a summary of also all this. So like I currently have an account with the private keys and other stuffs, but I can get that external wallet into Bravos, just like getting a Trust Wallet account into MetaMask. So it will depend, right? Because remember, the way the wallets are structured in Starknet, it's not the way like another external wallet is structured, okay? Because example, if you're saying like you want to import like your MetaMask account or another wallet into like Bravos, remember they're two different things, the system design-wise. Because when it comes to Bravos, it's more of a smart contract. When it comes to this other end, it's more of like an external account, okay? Which just has like a private key. It's not like a smart contract. Okay, so I think because the system design will be different, it will be, I'm assuming it will be like super difficult trying to like import, let's say, like an external wallet, like let's say MetaMask, into a smart contract wallet, like Bravos. Yes. Okay, any more questions? Okay, nice. So do we have any more questions and more feedback?
Actually, I I was asking ChatGPT before, so I just want to clarify something. You know, I want to
Okay,
understand something.
okay.
Rust is the language which is used to write Solidity, and Solidity, I think, is built on Ethereum blockchain. Am I correct? Or I'm mixing things up?
And can you repeat? I couldn't hear you like properly.
The way you said we are using Cairo as a language to develop smart contracts for Starknet, right?
Yes.
When we use Rust to develop smart contracts on Ethereum,
Mm-hmm.
you understand? We know that is on the Ethereum blockchain. And what I can see here now is that Starknet is running on layer 1 and with layer 2.
Layer 2, yes.
Is it layer 1 or layer 2?
Starknet is a layer 2, but it settles on layer 1. So yeah.
Okay. So what blockchain can we, as a decentralized system, what blockchain can we classify that? Can we classify Starknet on?
You can call it like a ZK rollup in terms of if we are classifying blockchains, because Starknet is a layer 2, right? And we have different types of layer 2s. So with Starknet, it's now called more like a ZK rollup, because it tries to implement like a lot of cryptography and a lot of zero knowledge proofs to, execute transactions on behalf of Ethereum. So that's where you could classify it. You could also, I think, we could like lightly classify it to other chains like Scroll, who are trying to like build the ZK version of the Ethereum virtual machine, and any other protocol which is trying to like implement ZK. So they loosely like come into the same aspect of blockchain, where they're trying to implement zero knowledge and other cryptographical methods. Yeah.
So let's just say basically ZK chain.
Yeah, like a ZK chain.
All right. Thank you.
With the
Okay.
paymaster. Yes, yes.
Okay. I think there's another question.
So it's not different. Okay, let me first start with a Tadobiola. So when we talk about writing like a smart contract wallet, that's now what we term officially as account abstraction. So they're not different. Okay, so it's just like you're just writing a smart contract wallet, but in official terms, it's called now account abstraction. Account abstraction, it's like the methodology behind it, but the way you write it, you're just writing a smart contract wallet. So it's not like it's not like you'll say like there's an account abstraction wallet or something. You just call it a smart contract wallet, but officially that methodology is now called account abstraction. Yes. Have I answered your question? Okay, so with the paymaster, I've worked with a blockchain that has a similar structure, if I'm not mistaken, with a blockchain Zion that calls this treasury. This gives the ability for yeah. Okay, let me first finish with praise and then I'll get back to you. The other blockchain Zion that calls this treasury, this gives the ability for the
Hi, can you
developers
hear
to
me?
pay. Yes, I
This
can
is
hear you.
okay. I think I should explain better on call. So now I've
Okay.
worked with blockchain like Zion and ICP, Internet Computers, and there is this system where a developer gets to pay for the gas fee. On ICP, it's called cycles. So you pay for cycles, you host your canisters, which the users on your platform do not need to pay anymore. And on Zion, we have something called account abstraction as well, where a user gets to get their wallet through their email address. So they just put in their email address, get a code, and their wallet is created. Then there is what we call a treasury account, where you get to transfer some Zion tokens into as a developer and link that with the smart contracts, where any user that is interacting with your platform, that particular Zion token will be deducted. So it's more like an intermediary person paying for them. So is this similar to what the Starknet has? Is it the developer that pays for the user's transaction?
Not really. So if you okay for so based on what I told you guys, because there's some time back, Starknet said that for developers who are building for their users, the users will their gas fees will be paid for, but it's not the developers who are paying for the gas fees, right? It's now Starknet in itself. So the Starknet will come in as a paymaster. So if they know, like let's say you've built a product and people are using it, and and you want to give them like for a certain time they want to like transact free, so Starknet will now come in as a paymaster and they will pay the gas fees on behalf of all the people who are using your product. So that essentially it's what that means. Actually, when I send the resources to the Telegram group, when there's a time we were playing a game, was it for flipping? It was a game for flipping. I'll look for it. It was like a really nice game in Starknet where you like a you you're competing against an AI, flip like blocks or something. It was a super nice game. But now when you check it, you're just flipping. It's not like you're creating like an account and for every movement you have to like sign a transaction and pay gas fees. So it was so nice actually because they were paying the gas fees on behalf of everyone who was playing that game that time. So that's the whole concept of like a paymaster. It can be anyone. So if you're a developer and you create a product and you decide like as an offering for the first, let's say 500, 1,000 users, they'll interact with your product and they won't pay any gas fees. So essentially you come in as a paymaster.
Okay, all right. So why I asked the question is because one of the reason why adoption is quite slow for some blockchains or for blockchain is because of the transaction fee, which
Yes.
requires most of these people to have, and it reduces the adoption rate.
Yes.
I've built on different blockchain and intend to build on Starknet as well. And one thing I have decided is that for every application I build, I myself gets to handle the payment, since most of the application is going to be on a subscription base. So is there a way I can actually implement this myself as a developer, that I get to pay for the user's transaction? So the users actually do anything on the site for free from their end. Is there a way I can do this from my end?
Yeah, so it depends actually. So if you decide you'll build your own wallet, I'm assuming if you were to use like the default wallets which are available, like Bravos or Agent, I would be sure that they have that feature where someone can come in as a paymaster, right? But let's say you're building a product and it will come with its own wallet, right? So you can actually add that feature in your smart contract logic whereby you come in as a paymaster so that people won't have to pay like the transaction fees. You can actually pay the fees on their behalf. So the smart contract wallet will just be triggered, right? So anytime someone is like transacting, that a transaction is triggered, and then obviously when we talk about a paymaster, let's say we have like a treasury and you have like a certain amount of tokens, right? So you now use those tokens to pay for gas fees for anyone who's for anyone who's doing what? Anyone who's using your product. Yes, I
Okay.
think yes. Kasui, yeah, I can see Kaswini has like opened his.
All right. Hi everyone. Well done, Cyndie. Good job so far. Yeah, based on the question that Guy was talking about. So, um Starknet is a public blockchain, and public blockchain don't have you have to pay for your gas fee. Now, if you want to handle a scenario where, as a developer, you handle a scenario where you have to pay for the gas fee on behalf of the users, so that users can have a wonderful user experience, then you have to, on blockchains like Ethereum, they have what they call relayers that handles that. So I don't know if there's a let's say a platform that handles that on Starknet, but you can play around gas relayers. So a relayer is basically an account you're going to fund. So whenever a user is trying to interact with any smart contract, that relayer will pay the gas fee on behalf of that user. So you can play around something like that, but it's not an inherent feature on Starknet. So the Paymaster store, what Paymaster basically does is Paymaster gives you the ability to use any token on the Starknet ecosystem to pay for gas fee. For instance, normally on Starknet, you pay for gas fee using Stark or using Ethereum. But with the Paymaster, you can decide to pay using maybe the broader token or maybe your USDT or USDC and all of that. So I think, it's something you can play around with and, come up with a way around it. As a dev, there's no limit to what you can do. So I just want to add that.
Yeah, thank you very much. I think once I start building, I would be sending you more details so you can assist as well.
Okay, so thank you so much, Cyndie, for that beautiful session, and thank you as well, Cass, for the contribution. So we need to round up now. We have spent 20 more minutes in addition, right? So if you have any other question, you can just tag Cyndie on the Starknet Africa channel, right, to ask your questions, right? And then the recordings will be live by tomorrow morning. It will be shared, as well as the assignment. So your assignment for week 1 would be shared tomorrow, and the submission form as well. So you're expected to have your assignment submitted on or before the next class. That's on Tuesday next week. Yeah, before the next session. So yes, we have come to the end of today's class. Thank you once again, Cyndie, for the amazing session. It was really enlightening. Thank you so much. And Cyndie will be back by week 3. Yes, you'll be teaching building on Starknet. So yeah, thank you everyone, and have a great night's rest. Bye everyone.
Hi, and just before you like close the live, I just
Okay.
wanted to tell everyone you can forget everything else because we've talked about so many things, but don't forget the architecture of Starknet. Always remember like the bar analogy, right? So we start with the bouncer, we go to the waiter, and then we go to the cashier, and then you go to the manager, right? So that translates to like the mempool, and then you go to the sequencer, and then you go to the prover, and then you can go to the verifier. Yes. So just always remember that when you like even go tomorrow to like have fun, just always relate it to Starknet.
All right, thank you. Thank you, Cyndie. So I think we can close the call today. All right. Bye, everyone. Bye. Bye, Cyndie. Bye.
Bye bye.
Bye.
Okay.